How was Fourier's law discovered for thermal conductivity? Imagine trying to understand how heat moves through a metal rod or a piece of wood. It might seem simple, but figuring out exactly how that heat travels took a lot of thinking and math. That's where Jean-Baptiste Joseph Fourier comes in. He was a French mathematician and physicist who wanted to explain how heat flows inside solid objects. Back in the early 1800s, he started studying how temperature changes over time and across different parts of a material. He asked himself, how exactly does heat move from the hot side to the cold side? Fourier believed that heat doesn't just jump randomly, it moves in a predictable way based on the temperature difference. He thought that the rate of heat flow depends on how steep the temperature change is across the material. So, if one end is much hotter than the other, heat will flow faster. He set out to turn this idea into a mathematical formula. His goal was to describe this flow precisely, so engineers and scientists could predict how heat moves in different situations. In 1811, Fourier entered a mathematics contest and won a prize for his ideas about heat transfer. But he was hesitant to publish his full work because he wasn't sure how others would receive it. Finally, in 1822, he published a book called The Analytical Theory of Heat. In this book, he introduced a key concept called the heat equation. This equation describes how heat spreads through materials over time. It also laid the foundation for understanding thermal conductivity, which is a property that tells us how well a material can conduct heat. Before Fourier, scientists knew that different metals conducted heat at different speeds, but they didn't have a clear explanation. Some experiments showed that copper conducts heat faster than iron, but there was no way to predict or explain why. Fourier's big contribution was to create a mathematical framework that linked heat flow to the temperature gradient, or how quickly temperature changes from one point to another. This was a breakthrough because it turned a physical observation into a precise formula. Fourier's law states that the amount of heat transferred through a material per unit area and time is proportional to the negative of the temperature gradient. This means heat flows from hot to cold areas at a rate that depends on how steep the temperature difference is. The proportionality constant in this relationship is called thermal conductivity. It's a property of each material that measures how easily heat can pass through it. Metals like copper and aluminum have high thermal conductivities, so they transfer heat quickly. Materials like wood or plastic have low thermal conductivities, meaning they are better insulators. This discovery was important because it helped scientists and engineers design better heating and cooling systems. It also became a key part of thermodynamics, the science of energy transfer. Today, Fourier's law is used to calculate how fast heat will move through walls, pipes, or electronic devices. It's essential for making sure buildings are energy efficient and electronic gadgets stay cool. So, Fourier's law was discovered through his careful mathematical analysis of heat flow. His work turned observations into a formula that explains how heat moves in solids. His 1822 publication gave us a clear way to understand and predict thermal conduction, and that's why his law remains a cornerstone in the study of heat transfer and energy today.